So after some brutally long videos, let's look at a short one here. Thinking about our functionality on where our reactivity comes from and what functional groups are. One of the biggest drivers, I should say, is electronegativity. So having an idea behind what electronegativity is and what their relative electronegativities are of your individual elements is useful. Okay, so when we're looking at an individual functional group, we're taking two atoms and we're connecting them through a bond. And then we're saying, how does that bond, where does it fall as far as reactivity? And if we have a large difference in electronegativity, that creates a certain level of chemistry associated with it. And that chemistry is ultimately about how does it find other atoms or molecules to balance out that charge so we get less charge. So pretty much everything we're doing is trying to strive for some level of neutrality. And there's varying ways to do that, but electronegativity tends to be one of the bigger drivers behind it. So you should memorize some electronegativities, and in particular their rankings. Their absolute values behind them, for instance, fluorine being 4, isn't super critical, but knowing that fluorine is the most is. Knowing that oxygen and nitrogen are second and third is also useful. Okay. After that, I don't really have them memorized, but fluorine, oxygen, nitrogen, if you remember from 151, hydrogen bonding, that's why hydrogen bonding was so strong, is because of fluorine, oxygen, and nitrogen. There are other elements that have similar electronegativities like chlorine, and they have features that approximate the potential for hydrogen bonding or strong interactions, but they aren't quite there yet. So if you got that electronegativity down, that should help out. Okay? After that, of course, I'm not connected, so let's try that again. We're looking at our same core elements, hydrogen, carbon, nitrogen, oxygen, and our halogens, and then we're saying what happens when we connect them. So we addressed sigma versus pi bonds. So what we're looking at in this case is that if we take a hydrogen and we sigma bond it to a carbon, how is that different from a hydrogen sigma bonded to a nitrogen? Does that change the chemistry? Well, it does enough, and that's why we're getting a nomenclature change. Why we'll refer to it as an alkyl group versus an amine versus hydroxy versus acid. And then we can do the same thing by switching carbon to carbon, or nitrogen to carbon, nitrogen to oxygen, nitrogen to chlorine. And how does that change our group? For the most part, the functionalities shown on this page are the ones that you're looking for. Okay? So we don't see the nitrogen to oxygen, the nitrogen to chlorine very often, and we don't reference them. So don't stress about those. Okay? When we bring in the pi bond, same idea, carbon, carbon. First we have the sigma, then we have that pi. Does that give us a new functional group? If we have multiple pi bonds, does that give us even more functional groups? And yes, that's the layering we're addressing. So what we're looking at here are our simplest functional groups. What do I mean by simplest? Well, could we combine functional groups? For instance, could I say, and ignore the Y different names for the moment, could I say take a hydroxy, an OH, and what happens if I put that near a carbonyl? Does that change the chemistry of any of those aspects? And it turns out that yes, indeed it does. This functional group makes this hydrogen exceptionally acidic. Because that hydrogen is so much more acidic than it was in the hydroxy, I need a new name. Okay? And that's kind of the stacking behind these names. The names are really just coming from how do you address the different reactivities? How can you put it together?
I'm gonna go on a walk.
Okay, can you give Daddy like 5 seconds?
Yeah.
Okay. Okay. So we'll try and finish out this video. If we combine multiple functional groups, we get a new name, and thereby we need a new chemistry to address it. Okay? So functional groups. I highly recommend that you memorize these so that when you see them pop up, you recognize their functional group chemistry and you can identify some of their reactivity. When it comes to this semester, the functional groups that we are going to talk about as far as chemistry: alkanes, alkyl halides, alcohols, ethers, it's okay, alkenes, and alkynes. Okay, so a little bit we'll look at carboxylic acids and amines, but we're really looking at those at the simple base level. Okay, the other functional groups, ethers is kind of a blend, so we might call that one purple as far as our memorization goes. Aromatics, aldehydes, ketones, carboxylic acids, amines, and to a certain extent our alkynes and our alkenes will also get addressed in second semester. Okay, so if you're only first semester, you still need to be able to identify these functional groups when you see them. You just won't be spending a lot of time reacting them with anything. Okay, the last thing that I want to address before I get chased out, clearly, is that we've got kind of shorthand notations in here. So you can see some of these abbreviations. CHO is a really common one. Note that that's written left to right. So when we talked about that condensed formula, aldehydes was one that I was referencing. You wouldn't see a formula CHOCH3. Yeah, because that wouldn't make sense. We would start to draw the wrong conclusion. But if we spun that around and wrote CH3CHO, now it makes sense. So some of these have kind of that organizational structure behind them, some of them don't. So what you should do is review not just the drawing, but then also the condensed formula that's kind of written underneath it and the name, so that you're familiar with what these things look like, so that when they pop up, you have a little bit more context of what they mean, both in a draw the structure for this formula and also a here's a structure, how does it react kind of system. Because once we bring in that react, you need to be able to recognize a lot of these things that are up here. Okay, with that, like I said, short video. Hopefully that works. Let's make sure there's no more. Yep, we're good.